Welcome to Reality Creative Video. I'm Hermes. Today I want to talk about copper. I know I've talked about copper before, but I had an oops in the lab, and that oops. Sometimes oops in the labs can bring enlightenment and all sorts of other things going on. So I had an oops. So I'll put a link in the description to my making copper start to finish. And if you followed my copper journey along the way, you know that I talk about two different kinds of copper, Cu+1 and Cu+2. And that refers to the oxidation states of copper. There's actually 3 oxidation states of copper, but the third oxidation state is not stable at all. Doesn't stay. So really, anyway, I always cook. In the beginning, I used to cook Cu+1, and then I would cook Cu+2, and then I would combine the two. And the reason I combined the two is I sampled both. Cu+1 and Cu+2 are actually two distinctly different kinds of copper. And, it's also speculation on whether I'm cooking Cu+1 and Cu+2, but I'm pretty sure I am. One of the things is I found out that, I cooked Cu+1 and Cu+2, and I tested it on various things, and I found that each one had good purposes to it. I had positive stuff. So I said, well, maybe I'll just combine them. So that's what I started doing, combining Cu+1 and Cu+2. And then I found it was like truly magnificent when I did that. And unlike other colloidals, if you take two different, other colloidals do not have two different states. They don't have a 1 state and a 2 state, all right, like copper does. So you can take Cu+1 and Cu+2, you can mix it together into one batch, and it doesn't change. It stays. You got a batch of stuff with Cu+1 and Cu+2 molecules in it, and I can show you a video picture that right there is Cu+2 on there. And then I'll show you a video picture of Cu+1 and Cu+2, how it looks on the microscope. And as you can see, it's distinctly different, the two different coppers. Cu+1 is much more dense and compact. And Cu+2 is larger, more rounder. And when you mix them together, you get kind of like a amalgam of the two of them. And this is what brings me to today's discussion. Now, the reason I find copper is so important to me is my nasal spray. Before I invented this nasal spray, I was on 4 different allergy medicines to control my allergies. I had raging infections in my ears and my sinuses for years, and I've tried a lot of different things. And when I discovered the Cu+1 and Cu+2 together. So, and as you know, my latest copper start to finish creates a solution of Cu+1 and Cu+2 in one go in an hour. And it actually comes out perfect that way, and it's quick and it's easy. Now, if you cook Cu+1 by itself and you cook Cu+2 by itself, you're looking at 2 hours. A process for each, 4 hours. So something magical happens when you combine the two in the right exact way. But there's the oops factor, and that's what brings me here. As you can see, this was supposed to be Cu+1 and Cu+2, which is supposed to be a cyan greenish color. This is green. What happened was I got a phone call, and I was on the phone, and instead of cooking my C1, C2 copper for an hour, I cooked it for 2 hours, and I wound up getting too many particles of Cu+1 in there, and the whole solution turned green. I've put it in the video microscope, and I verified that this is probably about 80% Cu+1 and 20% Cu+2. Which is not going to cut it for my nasal spray formula. So I could just start from scratch and toss this stuff out, but hey, there's a learning experience and everything. My learning experience is I'm going to rescue it. How am I rescuing it? I am cooking Cu+2. This is my first batch of Cu+2. Took 2 hours to cook. You can see it's a bluish color. And you put the two together. You can actually clearly see the difference. And I can show you some pictures I took of in a beaker of the difference between Cu+1 and Cu+2 in color, the oxidation state. And I'm going to combine these. So, but this is such a high percentage of Cu+1 molecule, I'm going to need quite a lot. So I'm probably going to be looking at least 2 liters worth of copper, of mixing Cu+2 with this little bit of Cu+1. So I'm probably going to have to do a liter of this into this in order to get me the middle Cu+1,2 thing that would have just cooked perfectly had I not overcooked it. So yeah, you may want to set timers for yourself and actually listen to them when the timer goes off. When you're cooking stuff like this, that is time dependent. Could save you a lot of headache. But like I said, I'm doing it because there's a learning experience to it. I certainly could toss this stuff out. It would be a lot faster, let's face it, because you're looking at 2 batches of 2 hours. That's 4 hours. I could easily make a liter of this stuff in 2 hours. So I'm actually going the long way around. But what fun is that, right? So I also wanted to show you, on this one batch that I overcooked. I got a brilliant picture of the oxidation on a copper rod. I'll show you what that looks like. It's absolutely beautiful. And that oxidation state is supposed to be Cu+1 and Cu+2. And as you can see, it's like a cyanish sort of green color, probably more cyanish. But because the the green molecule, the Cu+1 molecule is much more aggressive than the Cu+2 molecule, it took over the batch, turned it green because it didn't have the right 50% proportion in there. So I'm going to rescue it with this and probably learn something in the process. Hey, worst case, I toss it out. I'm out some distilled water and some copper, which is relatively cheap. But anyway, it made a nice show and a talk about the different states of copper. The other colloidals don't have 2 different states. They only have 1 state. So copper is special. And I find if you can go the extra distance and, use both states of copper in your mix, you will find it far superior to drinking either one, which is why the copper start to finish shows you how to do it in an hour together in one go. Just remember to set your timer on your watch to remind you not to overcook it, because then you're going to get green. So that's my little tirade on copper this morning. I got other videos coming up. I got a nice list of videos of, coming up. But I wanted to do a couple of videos that I just, off the cuff, kind of quick stuff, show you what's going on here in my laboratory.